Yes. Welcome to our daily tips on CNC programming. I'm using Shopton to do program. That is a Siemens 840D. And this is some of the part I'm going to show you how to program using Shopton. And then from there, in case you want to learn more on how to do Shopton with the other features like the milling features on a turning machine, you can come to a center. I will show you how to create a program on ISO at the same time on ShopTurn and ShopMill. So let's go to our Siemens controller. We see how we can create a simple program, and then we do a simulation. Added some features like here you see I'm doing a drilling, which is going in deeper to 8 millimeter deep, and then I'm also added here. So I'll show you some commands on how now to offset a new feature from here to here. At the same time, how to add maybe like a milling feature on turning machine. Let's go to our program. Okay, this is the program. I already have done the program because because of time I don't want to go deeper into what is needed. Okay, from this header, I will only show you the parameter that this is the maximum diameter of the stock. This is my stock. This is my stock. And then I'll have 1 millimeter for facing. That is for diameter. Then 1 millimeter for facing. Then this is the stock length. And then I'm turning it to minus 115. So you need to know how to calculate the overhang. You take the maximum diameter, that is 80 times 1.4, 1.4 to see if it will wobble or not. So 80 times 1.414, you get 113. So I'm within 119, so there's no wobbling here. And now let's go to retraction value for X diameter. For example, if this diameter is 80, I'm adding 10, so it becomes 90. Then for Z, retraction safety for Z is this, and then here I'm using machine coordinate teach. Then from there I can put the actual values for the machine, and then I'm using down cut with a safety clearance of 1 millimeter. Then accept. From there I'll come to do stock removal. I just click on turning, then stock removal. You see, I'll get this one. That's what we have obtained. You have to create a tool. I'm using CNMG 120408 with a feed of 0.3, then cutting speed which is constant at 150 millimeters per minute. On facing, stock is 80, 1 millimeter for facing. It goes almost to minus 1.6 or 1.8. Then this is the amount of material I'm going to remove, so that I remove 1 millimeter from Z0 to Z1. So meaning my new face will be 1 millimeter. Then I will create a contour. This is the contour. In case you want to learn this one, you come to a center. I'll show you how to get this contour, adding all the required what you call undercuts. As you can see from this one, we have the undercut here. We have the undercut here. How do you add undercut? You can come to a center. I will show you. Then OD rough. From here, OD rough. I'm giving what you call residual cut, video cutting. From residual cutting, I have this. Can come to, for example, I put here finish operation. Can come here, and then I say before cutoff, I paste here. Okay, accept. Then I'll say I remove this one, and then say this is for finishing. Change this one for finishing tool. Just for purpose of showing you, but if you want to learn this one, you can come to a center, then learn this more. Material is mild steel. I'm using these parameters. Okay, undercut, yes, for example. So this is how you create, and then from there, I came to add the groove. This is the groove. How many? There are two grooves, as you can see. I'm using groove 4 millimeter groove width. Then there are two of them. So how do you add two groove? As you can see from the drawing. Maybe let's go to the drawing. You'll see from the drawing. From this drawing, you see here there are two grooves. They are only giving you that one groove is 8.8 millimeter. Then from this 8.8 millimeter, you need to calculate distance from here and distance from this point to this point. So it's good to know mathematics, basic mathematics. So let's go to our session. In this program, you see this groove. There are two of them. down here there are 2 of them, and then this is the width of the groove. It is drilling to the meter 52 from 45.6. So you need to calculate this. You are not given, but you are given 60, which is at the center. Okay, and then from there I have a center drill. I'm doing on per surface C. You can see this per surface C. I'm doing the center drilling on per surface C. Then from there I'll do deep hole drilling on the per surface C. And then from there I do the position now, how many positions I want to drill. Then from there I offset, because it's only that there are only 2 from the drill. Let me show you from the drill. These are the drills. So these are the holes. From this center that is 50. So 66 minus 50, you get 16. So I'll show you how to do this. Let's go. Now you see this one I have done what we call offset. Z going minus 16. Then from there I say now do center drill again. I just copy this one and then I paste there. Okay, and then from there I want to come back. Remember, I want to come back to do threading. Let me show. There's this threading. After I've done the offset from this point to do the drilling, I want to come back and do what we call threading. In case I only do without returning from where it was to here, then automatically it will not read this value. It will be reading from this point as it goes. So how do we do it? This one. So this is what I've done. After offsetting to Z minus 16, I turn to Z16. Additive, that is incremental. Then I now again return it to Z0. From now, that one from the Z0. Then I now did threading. My threading is a pitch of 1.5, digressive external with a diameter of 30 by 2 by 1.5 from 0 to minus 17. As you can see from this graphic, you're able to see this is the thread. You see the thread. Okay. And then from there, I now rotated this one and diff 60 degree. And then from here, I want to repeat how many times. That is, I want to use macro programming, Mark 1. I go to contour. Now, this is my contour. I'm starting from this per surface C, diameter 60 to this, then next to this at an angle of 180. Then I go to do path milling, but path milling using a center. Then from there, I rotate again to 60 additive. Then from there, I do the same, which is not needed, but for the purpose of this one, from there, I repeat a second mark. See this? Then repeat how many times? 5 times. From there, I go to multi-edge on the face C, for face C, as you can see, face C. And then from there, I do a finish contour, direct, using this finish contour. I go to now cutoff, but remember, if you're using cutoff, you need to use the blade tool, the blade. Now, let's do a simulation. We see where the error is, we remove the error, and then we see how we're able to program. Now, click here, simulate. You'll see it will give you error in case of an error, and then from there you're able to troubleshoot. So this is what we call programming and troubleshooting. In case you want to learn how to troubleshoot this program or programming in Siemens, you can come to a center in Karen. That is 5-Axis Precision Academy. Will train you, will guide you on how to rectify this problem, on troubleshoot in case of any error and rectify. As you can see now what it's doing. Maybe I can repeat it for the sake of those people who want to understand it. I'll explain the process one by one as it goes. First operation, it is starting from facing. Then rough turning. It goes to what you call residual cut, grooving. From grooving, I want to do now offset, drilling, center drilling, then drill. From drill, then come again to offset to minus 16, as you can see, center, then drill. Yes. Then now return to Z minus 16, Z16, then do this milling. You see, this is what a turn mill is. So you're able to run a program such a way that it's able to catch up with what is needed in the machine. This is a turn mill. Then from there, I can do multi-edge on the face C. Then I do finishing. Then from there, cut off. So this is what we have. As you can see, this is what we have as your part. This is what we have. Then, because I've done C-axis, I can say now, let's go home first of all. Let's go home. This is the DMG MORI machine, don't worry. Let's choose this one. Then let's say L708, blah, blah, 708. Enter. So you can see this one, same as that one. So it's like changing tool. So this is the same as this. So I can remove this one and I can maintain this. That after finishing, you go home. Then from there, I'm telling my spindle to stop axis, or I can use what we call SPOS. SPOS 4 equals to 0. Then you can say, I can say M4 equals to 5, like that. So this is how you create a program. And then I can say start here, because I want to rotate my spindle doing centering. I can say here L707 into 1, like this. Then if I put here X, the angle is 1. But if I don't want angle for 1, I put 0, enter. Then I accept. You see here now, switch on the C-axis. Because I'm using C-axis, I'll be using this. Switch on the C-axis. If I'm switching on the C-axis, it is telling me that I'm going to use the C-axis spindle as a C-axis. So this is what you do when you are programming. You see, this is what you do when you're programming. These are languages you need to understand when you are programming. And there is a way you can also set, you can say maybe set master spindle, blah, blah, 4, blah, blah, all of this you can say limit spindle speed equals to 3000 if you're using ISO programming. But this one I'm using Shopton, so already each parameter has been set in the program header. This is the program header. I've set all this program here that my maximum cutter speed is 3000, and this I'm using S4 spindle number 4. That is channel number 4. Okay, this is how you create a tournament program in Siemens 840D using DMG MORI machines. Come to a center, you learn this on how to create programs.